In the second part of this lesson, we will solve logarithmic equations. So step 1, isolate the logarithm. Step 2, if necessary, write as a single logarithmic expression. And then remember that logs and exponents are inverses. So in order to solve a logarithmic equation, we will rewrite that as an exponential equation. And then we solve. We have a note here, which we'll come back to later on. Okay, so here we have log base 3 of x equals to 5. This is a logarithmic equation, which means to solve it, we will have to rewrite that as an exponential equation. But is a logarithm isolated? Yes. Do we have a single logarithm? Yes. As long as the first two steps are met, we can go to step 3 and write this as an exponential equation. So the base of the log is going to become the base of the exponent, and then the x and 5, they interchange. So we have 3 to the 5th equals 2x. And if you multiply 3 5 times, or put this in a calculator, we're going to get x equals to 243. Okay, let's take a look at part B. We have 4 times log of x equals to 8. First step is to isolate the logarithm, which means we need to divide both sides by 4 in order to get the log by itself. So now we have log of x equals to 2. Now, if the log does not have a base, if the base is not written, then this is going to be base 10. So we're going to say that the base of the log is 10, which means the base of the exponent is going to be 10. The x and 2, they interchange, so we have 10 squared equals to x. 10 squared is 100, which means x equals to 100. Example C, we will do in class. Okay, let's take a look at example D. We have log base 2 of 3x plus 6 equals to 5. Let's go through our steps. Is the log isolated? Yes. Do we have a single logarithm? Yes. So now we go to step 3 and write this as an exponential equation. So the base of the log is 2, which means the base of the exponent will also be 2. The 5 and the 3x plus 6, they interchange, so we have 2 to the 5th equals to 3x plus 6. 2 to the 5th is 32, so we have 32 equals to 3x plus 6. We subtract 6 from both sides. And this gives you 26 equals to 3x. Then we divide both sides by 3. And our answer here is going to be x equals to 26 over 3. All right, let's go to the next one, letter E. We have log of x plus log of x plus 2 equals to 6. So step 1, isolate the logarithm. So none of the logs have a coefficient, but step 2, it says, if necessary, write as a single logarithmic expression. Before we can solve, we have to have a single expression involving logarithms. So how do we do that? So quick reminder. If we have log of m plus log of n, in other words, we have two separate logarithms and we want to write them as a single log, then the addition turns to multiplication. So in this case, if we wanted to write two separate logs as a single logarithm, we have that single logarithm, and addition turns to multiplication. So we have log of x times x plus 2, and that equals to 6. Okay, now the log has a base 10, right? So we're going to have 10 to the 6th power equals to x times x plus 2. So 10 to the 6th power is basically a 1 with 6 zeros. And you can also do this in a calculator if you wish. 10 to the 6th power equals to 1,000,000. So we have 1,000,000 equals to x squared plus 2x. Now we can tell that this is going to be kind of a large expression. So what do? We need to, so anytime you have a quadratic, we need to move everything to one side. So I'm going to subtract the 1 million to move it to the other side. So I have 0 equals to x squared plus 2x minus 1 million. Now, I don't know about you guys, but if I want to try to factor this, it's going to take a long time. I got to find two terms which multiply to be a million and add up to be 2. I feel like that's just going to take forever. So um, you have two choices at this point. You can either use a quadratic formula, or you can go to Desmos and you can graph this, which is what I'm going to do. So I'm going to Desmos and I'm going to graph this. Obviously, on a test, you won't be able to, but for homework you can. So I have x squared plus 2x minus 1 million. And my solutions are going to be the points where the graph hits the x-axis. So my solutions are going to be 999 and negative 1001. Those are my solutions. So my solutions are going to be x equals to 999 and negative 1001. If you were to use a quadratic formula, you would get the exact same thing. Okay, but to save time, I'm doing it this way. The domain of any logarithm is such that, so if we're given log of x, the domain is x greater than 0. This was one of the first things we learned in our definition of logarithms. The value of x always has to be a positive value, which means the negative 1001 is not a valid solution. And our only valid solution is going to be x equals to 999. The key here is to remember to write the left-hand side as a single logarithm. And to write that as a single logarithm, we got to use this property where addition turns to multiplication when we go from two separate logs to a single log. Okay, let's take a look at letter F. Letter F says we got log of x plus 5 minus log of x plus 1 equals to 1. Another quick reminder, if we have log of m minus log of n, so if we're subtracting two separate logs and you want to write them as a single logarithm, then subtraction leads to division under a single log. So what do we have? We have log of x plus 5 divided by x plus 1, and that equals to 1. We have two separate logs. We always have to write them as a single logarithm if we have multiple logs, which we did. And subtraction leads to division under the same log. Now we can solve this by converting this into an exponential equation. So once again, the base of this log is 10. So we have 10 raised to the first power equals to x plus 5 divided by x plus 1. So remember that there's an invisible 10 there. So 10 to the first equals to x plus 5 over x plus 1. Now 10 to the first is 10. So we have 10 equals to x plus 5 over x plus 1. To solve for x, we can't have a variable on the denominator. So the first thing we have to do is we need to multiply both sides by x plus 1. Multiply the left side, multiply the right side. Okay, and when we do, the x plus 1 and the x plus 1, they are going to divide to 1, so we can cancel those out. And then here, on the left side, we have 10 times x plus 1, which if you distribute that, we get 10 times 1 is 10, and 10 times x is x. So we get 10x plus 10 equals to x plus 5. Now this becomes a simple equation. We need to get all the variables to one side. So I'm going to subtract the x's. And then I need to move all the constants to the other side. So I'm going to subtract the 10. And again, I'm doing this in one step, but feel free to do it in two steps if it makes you feel better. So we have 9x, the 10 minus 10 is 0, x minus x is 0, that equals to negative 5. And if I divide both sides by 9, I get x equals to negative 5 over 9. All right, letter G, we will do this one in class. All right, let's do one more, and then we'll do the rest in class. So letter H, it says, we have log of x plus 15 equals to log of x plus log of 15. First thing is we need to write each side as a single logarithm. The left side is good. We have a single logarithm, which is log of x plus 15. On the right side, we have two separate logarithms, which we have to write as a single log. So when we have two separate logarithms that are being added, when we write that as a single logarithm, that addition turns to multiplication. Now here is where we go back to the note. In all the other problems prior to this, we have logs on the left side, but only a number on the right. We have logs on the left side, but only a number on the right. In letter H, however, we have a logarithm on both sides. So that takes us to our note. The note says that if log base b of m equals to log base b of n, then m equals to n. In other words, if we have a logarithm on both sides, then the only way that these two sides could be equal is if the m was equal to n. So we use that only when we have a log on both sides, like in this case. So because we have a log on the left, because we have a log on the right, we don't have a log on the one side and a number on the other. We can just say that we can kind of ignore the log because it's common to both sides. And we can say that x plus 15 equals to 15x. Now we got to move all the variables to one side. So I'm going to subtract x from each side. And this gives me 15 equals to 14x. Then I divide both sides by 14. And finally, I'm given that x equals to 15 over 14. Okay, and then letter I and letter J we will do in class.